Hello, welcome. This video is about how to graph from Vertex form. Um, Typically, you'd be given an equation in Vertex form and then graph it. In this case, we've got a graph, and we have to write the equation in Vertex form. And so we're going to kind of work backwards from that. For that, I think it's useful to know what is the generalized form. We've got y equals, now if you would prefer y, you could write f of x. It's the same either way. So y equals a times x minus h squared plus k. And the vertex from this form is the point h comma k. Notice it's not negative h. So this always kind of looks like it's the opposite. So from this graph, we can say, well, here's the vertex right here. We can say that point, it's 1, 2, 3, 4 over in x, and then 1, 2, 3, 4, 5 up in y. So it's the point 4 comma 5. And then I already know my vertex is the point 4 comma 5. Direction of opening, I can see that it opens down. Now, about that, I know that a will then be less than 0. In other words, a will be negative. And and I can read also from the graph that my y-intercept is that point. You look real close. It's not right here at negative 10. So do look very close. It's that point right there, and that's down at negative 11, and that's so it's 0 in x, negative 11 in y. Careful not to switch these x and y values up. It's really easy to get those confused. X is left and right, y is up and down. So my y intercept is the point 0 comma negative 11. Axis of symmetry is always the same as the x coordinate of your vertex, and so it's x equals 4 is the equation of this line here, which technically speaking is not part of the parabola, but it helps us to make sure that we're graphing it correctly. And so the only thing that we really don't know, is a. We don't know what the value of a is. And so that we can find out. A lot of times you could just, you could guess. We're in a math class. We're trying to make it easy for you. You might guess that a is 1. Because a is going down and a is negative, you might guess that it's negative 1. But you can determine that for sure by just plugging in the values of what you know. So we know the vertex is the point 4 comma 5, and we know a point, let's say even just the y-intercept is some point x and y on the graph. And so this point y and this point x, we know we can take from the y-intercept or any other point. There's several here points that are kind of labeled. We could use that one or this one or this one. Any one of them will do, but I'm going to choose to use this one down here, that point 0, negative 11. So then we just plug them in. Let's put a little color to this. Let's say that's my vertex, and that's my y-intercept. And so my vertex is going to go here and here, and the y-intercept is going to go here for x and here for y. And then the only thing that we won't know that we can solve for then is that a. So we're going to go here and say, well, okay, y is negative 11. And that's equal to a times x, which is 0, minus h, which is the x-coordinate 4. That's going to be squared. And then plus k would be plus 5. Just to put the color back in so you can see kind of where we made those substitutions. That's the 4 and the 5. And then there's the 0 from my y-intercept, and there's the negative 11 from the y-intercept. And the only thing then we need to figure out is what is that a value. So we're going to just kind of work through this. I've got negative 11 is equal to a times, and then 0 minus 4 is just negative 4. So I got negative 4 squared plus 5. And negative 4 squared, that'd be positive 16. So then I've got negative 11 equals 16 times a plus 5. Again, this 16 is this negative 4 squared. I just switched it so that it's kind of the way that we're used to seeing it, with the coefficient first and then the variable. And so then I subtract 5. Subtract 5, subtract 5. And that's negative 16 is equal to 16 times a. And then finally dividing through by 16 would give us that a equals negative 1, which is what we thought it was going to be since it faces down. And so now we just have to put this all together. We're going to kind of rewrite this, but with x and y back in their place. X there and y, or y there and x there. So f of x, well, that's where the y was, is equal to, so let me just write it below here so you can see what we're doing. F of x, again, that is the same as y, is equal to a times x minus h squared plus k. And a we determined is negative 1, so I'm just going to write that as a minus sign. You could write negative 1 if you want, but I'm not going to. I want you to get used to knowing that it's there even if you don't see it. And then I've got x again minus 4 squared. See, then that's the 4 from the h in its place here. And then plus k, which would just be plus 5. Notice that minus, it doesn't correspond to this 4, which is actually positive. It kind of throws you off because it's x minus 4. But this is the equation in vertex form. One quick word here. If you took any one of these points, like let's say this point right here is the point 5, 6, 7. That's the 7 over to the right. And it's down 1, 2, 3, 4. So this is the point 7, negative 4, where x is 7 and y is negative 4. And you plugged those values in here, 7 in here, and negative 4 in here for y. Both sides should be equal because that point is a solution of this equation. So you can kind of verify if you've got the right equation by checking any point on there and see if it makes it a true statement.